What is the role of soil in relation to the climate? Hello, friends. Jim here. This is an article appeared on phys.org. Soil may release more carbon than expected, affecting climate change models. And here they have a little diagram showing some feedbacks. Overall in the center is dry, cracking land. You got increased temperature, leads to more severe and frequent drought, stressing out the crops in the soil, worsening soil desiccation and cracking, higher exposure of soil carbon to oxidation, increased CO2 emission to the atmosphere. Oops. Well, let's see what's going on. And they describe the cycle of drought, drying, cracking soil, ground, carbon release, increase in amplified feedback. The accuracy of climate models depends on many factors: greenhouse gas emissions, farm animal emissions, flatulence, urban growth, loss of forests, solar reflections of snow and ground cover, volcanoes blowing up. Right? All these things have to be factored in and incorporated into the models. Some other natural processes have been overlooked. Farshid Vahedifard, professor and Louis Berger Chair in Civil and Environmental Engineering, points to an important one that lies directly beneath our feet and covers most of the planet after water. In a study published in Environmental Research Letters, Vahedifard notes that soil stores 80% of carbon on Earth. And with increasing cycles and severity of droughts in several regions, that crucial reservoir is splitting open, breaking down, releasing even more CO2 and other greenhouse gases. Now, if you thought the thawing permafrost is bad, well, here's yet another source. In fact, it may be creating an amplified feedback loop that could accelerate climate change well beyond current predictions. 5 to 11C by 2100, anyone? This process has not been sufficiently evaluated in the existing literature or incorporated into models. If we don't consider the interplay of drought, soil desiccation, cracking, and CO2 emissions, that could result in significant inaccuracies when modeling and predicting climate change. There are other repercussions as well. Poor soil health can lead to reduced photosynthesis and lower CO2 uptake, not to mention crop failures, reduced crop yields. It can compromise the structural integrity of earthen dams that protect against floods. Now that's something I had not even thought about, but that's a really interesting point. There are also other amplifying feedback loops that may not have been fully accounted for in climate change models. These include melting of sea ice and exposure of darker ocean surfaces that absorb more heat from the sun. The increase of wildfires due to warm, dry conditions releases a lot of CO2 into the atmosphere, which in turn creates hotter, drier weather, more conducive to more fires and more CO2 reduction, right? We all know that as you burn the vegetation, CO2 gets released. Well, now you're also drying out the soil, which is going to release even more CO2, the CO2 stored in the soils. Another amplified feedback loop is the thawing Arctic and subarctic permafrost, right? We know about that. CO2, methane, right, gets released, adding to more thawing of the permafrost, adding more greenhouse gas releases, and so forth. But soil changes caused by drought could be as significant, if not more significant, than any of these factors. Drought, manifested by long periods of low soil moisture content and high temperature, leads to cracking in fine-grained soils, sometimes extending meters below the surface. The cracks result in more exposure to the air, increased microbial activity, and breakdown of organic matter, releasing CO2, as well as loss of nutrients and ability to support plant growth, reducing carbon dioxide sequestering. The deep cracks expose much older reserves of carbon that had previously been stable and protected. The permeation of air into the soil via these cracks accelerates the release of not only CO2 from organic matter, but also other greenhouse gases like nitrous oxide, which is also being released from the thawing permafrost. Small animals, earthworms, millipedes that help turn the soil over are also affected by the reduced moisture and increased air exposure. Basically, they desiccate, they dry out and die. So they're less able to be active. They have an active role in nutrient cycling and soil structure maintenance. They're going to be less able to do that. That's going to upset the nutrient cycling. It's going to impact negatively the soil structure. And that in turn leads to additional soil cracking and aeration. The amplifying effect of soil carbon feedback loops and its interaction with other loops could carry us across tipping points, lead to more severe permanent shifts in climate. So government agencies and policymakers need to promote sustainable land use, he said, which can include adoption of precision irrigation techniques and water conservation practices, use of drought-tolerant crops. Organic fertilizers and compost can enhance soil organic matter content, improve soil water holding capacity. But you have to tie this in with a comprehensive effort to reduce greenhouse gas emissions from all human activity. So, that's interesting. We know that as the air warms, it sucks the moisture out of the ground. Well, it turns out you're drying out the ground, you're cracking it, and then you're releasing more CO2. Yeehaw. It seems like we're now finding out many, many more such pathways that we have inadvertently created that are just making the situation far, far worse than we ever had thought or anticipated. So, drying ground, right? You're killing the plants, reducing the crop yield, and then you're enabling the soil to release its store of CO2 to the atmosphere, amplifying things even further. Oh, goody. There you have it. More bad news. Oh, and have a nice day. Talk soon.